students, welcome back. Today again chapter number 12, aldehydes, ketones and carboxylic acids I will discuss, and we will move further in chemical properties of aldehydes and ketones and discuss the remaining properties. The first property that I will discuss is Aldol condensation, then Cannizzaro reaction and then electrophilic substitution reaction. So let us move on to our first reaction, which is very important name reaction, Aldol condensation. See children, it is written reactions due to alpha hydrogen. Okay. Now since this reaction is because of the presence of alpha hydrogen, that is why we study this under this topic. Now before that, let us discuss the reason. Acidity of alpha hydrogen of aldehydes and ketones. Why is the alpha hydrogen of aldehydes and ketones acidic? Before that, let me tell you what is alpha hydrogen. Okay, as you all know, this is the carbonyl group which is present in both aldehydes and ketones. Right. Now, suppose if there is one carbon here, okay, then this carbon is known as alpha carbon. It can be on the other side also, and if there is a hydrogen attached to it, then this is known as alpha hydrogen. So the carbon next to the carbonyl group or next to the functional group is known as alpha, and if we go further and if there is one more carbon next to it, it will be known as beta and then gamma, this way. Now so the carbon, this carbon is known as alpha carbon, and if we have hydrogen attached to it, then it is known as alpha hydrogen. Okay. Now see, the aldehydes and ketones undergo a number of reactions due to acidic nature of alpha hydrogen. Since this is removed as H plus, and you know that removal of H plus means the compound is acidic in nature, so aldehydes and ketones will also be acidic due to this alpha hydrogen. The acidity of alpha hydrogen atoms of carbonyl compounds is due to, see, there are two reasons behind this. This is our first reason, the strong electron withdrawing effect of carbonyl group. Okay, this carbonyl group has a strong electron withdrawing effect. Okay, and the second reason is resonance stabilization of the conjugate base. Now see, this as it is shown, this bond moves and this H will be removed. Okay, and this conjugate base formed is resonance stabilized. That is why there is strong favor for removal of this alpha hydrogen. So these are the two reasons. First is the strong electron withdrawing effect of carbonyl group, and second is the resonance stabilization of the conjugate base. So let us study the reaction now. See, as the name is given, the name of the reaction is Aldol condensation. Now aldehydes and ketones having at least one alpha hydrogen. Now what is the condition? At least one alpha hydrogen must be present. Then only that particular aldehyde or ketone will undergo aldol condensation. Undergo a reaction in the presence of dilute alkali as catalyst. So what we take? We take a dilute alkali as a catalyst to form beta hydroxy aldehydes. These compounds, beta hydroxy aldehydes, okay, this one is known as aldol or beta hydroxy ketones. If we take ketones, then it is called ketols, and this reaction is known as aldol reaction. Okay. Now please understand the reaction carefully. See, here what is taken? Ethanol is taken. Okay, this is ethanol. Now first of all, let me explain again about what is alpha hydrogen here. See, if I write the expanded structure, then I can write it this way. CH3, CH3, CHO. Okay. See, now this is the carbonyl group present, and as I told you, the carbon next to the carbonyl group is known as alpha carbon. Now here if you see, in fact there are 3 alpha hydrogen present on it. Okay, so this is what is known as alpha hydrogen. Now if we talk about this reaction, see, we will take 2 ethanol, and in the presence of dilute NaOH they will give a hydroxy compound, in fact beta hydroxy compound, which is known as aldol. Now how this compound is formed? See, for this understanding you need to write down the reactant in this way. See, let me tell you. See what we are taking? Ethanol. So there are 2 molecules. So first you will write one here, CH3, C double bond O, and this is H, this is one ethanol. Now this will combine with the another molecule, which you should write this way. Now why we are writing it this way? Because see, alpha hydrogen of one molecule. So this side I am showing the alpha hydrogen of one molecule becomes attached to carbonyl carbon of the other. So this is the carbonyl carbon and this is the alpha hydrogen. So you need to write down in such a way that these two face each other. Okay, and you need to remember this is carbonyl group, this is alpha carbon, and this is alpha hydrogen. Now what you will do is, in the first, this H will come here, okay, and form the product. See, now simply you can write down this, the product CH3 CH OH, okay, this is single bond now, this is OH, then the remaining, this is CH2 and this is CHO. Okay, what we have done, we have simply formed the condensed product by attaching this hydrogen here in the form of OH, and rest the whole thing is written as it is. Now if you see this again, this is what our functional group, and this will be alpha carbon and this will be beta carbon. So this is known as what? Alpha beta product, or we can say that this is 3-hydroxybutanol. This is known as 3-hydroxybutanol. Why butanol? See, 1, 2, 3, 4. Okay, this is 1, this is 2, this is 3 and 4. Okay, so this is known as 3-hydroxybutanol. Now in further reaction, heating will take place and H2O will be eliminated. There is also a second step in this, in which, see students, here heating will take place and we will get the final product. In the final product, this will be eliminated in the form of H2O. So the final product will be CH3 CH double bond, here double bond will come, CH and CHO. Now see here, this is functional group, this is alpha carbon, this is beta carbon, okay, and the product is known as alpha beta unsaturated compound, and if you write down the IUPAC name, it will be but-2-enol. In second position, what is there? Double bond is there, ene and then ul. Now as you can see, there are 3 steps in this reaction, 1, 2, and in the third step we get the final product. But children, you can write down it in one step the final product. I will tell you the trick for that. So listen carefully. I am telling you this reaction again. See, as I told you, you have to write both the molecules in such a way that the carbonyl group, okay, carbonyl group faces the alpha hydrogen. This is H here, this is H, then this is CHO. See, I have written in such a way that this carbonyl group is facing the alpha hydrogen. Now what you need to do is, you need to remove 2 hydrogen and 1 oxygen. See, this oxygen and 2 hydrogen from here, and write the final product. So if we do this and start writing the product, see what we will get, CH3. Now here what is remaining, CH, then you will put a double bond and then CH, CHO. In this way we can get the product in a single step, and you can write all the conditions here together. What you can write, dilute NaOH here, dilute NaOH, and then you can show minus H2O and heat also. Right children? So this product is known as Aldol condensation product. Okay. Right? So I hope it is clear to you. The trick is, what you will do, you will remove 1 oxygen of the carbonyl group and 2 hydrogen from here. You will put a double bond in the middle and you can directly get the product. No need to write the intermediate. Okay. Now let us see. Suppose this is a second reaction that is given in NCERT. See children, this we have discussed ethanol 1 reaction. Now this is propanone reaction that is given in your NCERT. Again you will do the same thing. If you are not able to understand how this is being changed into ketol, you will write in such a way that the carbonyl carbon faces the alpha hydrogen. Right children? So if we do this thing with propanone also, see what you can do is, if I write here CH3, then CO, then CH3. See what I have done? I have just written propanone plus another molecule. How I will write? So that the alpha hydrogen faces. This will be the alpha carbon and this is C double bond O and CH3. Now as I told you, you can directly write down the product. How you can write down? You can remove this O and 2 hydrogen from here and put a double bond. So the final product will be CH3. Okay, CH3. Here what will come? Double bond will come. Then what is left? CH, CO, CH3. This is the final product. Okay. So I hope the trick is clear to you. Right children? So let us move on further. So this is the final product. This is the same as I discussed with you. Okay. This is the final product and this I have made it in the previous slide. Now see. The name aldol is derived from the names of 2 functional groups, aldehyde and alcohol. If you look at the intermediate, it contains both aldehyde and alcoholic group. So what is done? For aldehyde, ald, and for alcohol, OH is taken. That is why it is known as aldol. Okay, the aldol and ketol readily use water to give alpha beta unsaturated carbonyl compound, which are aldol condensation products, and the reaction is known as aldol condensation. Though ketones give ketols, okay, ketones will give a ketonic and alcoholic group, so they should be known as ketols, but the name aldol condensation still applies to the reactions of ketones due to similarity with aldehydes. Okay. Now see, if we use different aldehydes and ketones, the same reaction is known as cross aldol condensation. Okay. See, it is written when aldol condensation is carried out between two different aldehydes or ketones, it is called cross aldol condensation. If both of them contain alpha hydrogen atoms, it gives a mixture of 4 products. Okay, children. This is illustrated below by Aldol reaction of a mixture of ethanol and propanol. Now, in the previous reaction, we have taken 2 molecules of same aldehyde or same ketone, but in this, as you can see, one is ethanol and one is propanol. Now, in this case, we will get a mixture of 4 products. This is first, this is second, this is third, this is fourth. Now, if you see, you might be feeling how to write these products. Again, we can apply our previous trick and write down. See, what you can do is, one thing you need to remember that in this case, there are 4 possibilities. What are they? See, students, this, one second. This, if you see ethanol, it also has a alpha hydrogen. So, what is formed? Simple or self-aldol products. This ethanol will react with one molecule of ethanol, then give this product. And this propanol will again react with first of all one molecule of propanol and give self-aldol products. And in the second case, these two can react in 2 ways that I will tell you to form 2 cross-aldol products. So, let us see the reaction in detail. What is actually happening in the reaction? See, children. Suppose I take ethanol first. Okay. Since ethanol is a reactant, let me take ethanol first. So, ethanol we have already discussed how ethanol will combine. Again, I am writing that. See, CH3, you will write this way. Then you can write CHO. Okay, here it is O. Then you can write another molecule with alpha hydrogen facing towards it. Okay, this is H again, then this is CHO. And what trick you will apply? You will remove this oxygen and there 2 hydrogen and put a double bond here and you will get the product for ethanol. Okay, now let us see for propanol. You can do it in the same way. Now let me discuss cross aldol product. Okay, now see children, let me take the first reactant. CH3, CH2, C double bond O and here it is H. What I have written? Propanol here. Now here I am writing ethanol in such a way, see, so that what should be there? Alpha hydrogen must face here. Now what you will do? You will remove this oxygen and 2 hydrogen from here and directly write down the product. The product formed will be CH3, CH2, CH, double bond, CH, CHO. This is the product that you will get. Okay. And this is what? Cross aldol product, because one is ethanol, one is propanol and one is ethanol. Okay children, and this is known as pent-2-enol. The name for this will be pent-2-enol. Okay, now in this case, this is acting as an electrophile. This will be the electrophile and this will be the nucleophile. You need to remember. Now let us see the last condition in which what we will do. We will write this ethanol first, CH3, CHO if I write it this way, and if I write propanol in such a way. But here one thing you should remember, see this I have written propanol, this is CH2 and this is 3H. See, now here listen carefully, because this is the part where students make mistake. Now here you should remember this O you will remove, but this hydrogen, 2 hydrogen you will remove from where? Alpha carbon. This will be the alpha carbon, not this one. So you need to remove this hydrogen from this alpha carbon. So let me write down the final product. What it will be? CH3, CH, double bond C, CH3, CHO. What is it? 2-methyl but 2-enol. If you write down the name, it will come 2-methyl but 2-enol. Okay, so if you remember this trick, it will be very easy for you to write down the products with any reactants given. In this case, this will act as electrophile and this will act as nucleophile. I hope it is very clear to you now what is aldol condensation and what is cross aldol condensation. Now children, one more example is given in NCERT, which is for ketones. Ketones can also be used as one component in cross aldol. If one see here, what is taken? One aldehyde is taken and one ketone is taken. Now see children, what you will do? You will remove this oxygen and you will remove hydrogen from where? Alpha carbon. See children, this will be alpha carbon and you will remove 2 hydrogen and simply see, write down CH till here, then put a double bond and start writing from here. What will be left? CHCO and then the phenyl ring. So if you use this trick, then you will be able to write down the product very quickly. Now see, we are left with other reactions. See, what if alpha hydrogen is not present? Okay, one thing is left. Quickly I will tell you. See children, for the previous reaction, let me tell you the compounds which will not give the reaction. So HCHO, formaldehyde, C6H5CHO, benzaldehyde, C6H5CO, C6H5. This is what benzophenone will not undergo aldol condensation because these do not have alpha hydrogen. Now we will see some reaction which is known as Cannizzaro reaction, which is for these compounds which do not have alpha hydrogen atom. So let us discuss Cannizzaro reaction. Aldehydes which do not have alpha hydrogen atom undergo self-oxidation and reduction, which is known as disproportionation reaction on heating with conc alkali. In this reaction, one molecule of aldehyde is reduced to alcohol and while other is oxidized to carboxylic acid salt. So here what we have taken? Formaldehyde, and it does not have alpha hydrogen. In fact, it does not have alpha carbon, so it does not have alpha hydrogen as well. See, 2 molecules of formaldehyde will react and this is the reduced product in which they will form an alcohol, and this is the oxidation product in which they will form carboxylic acid salt. See, this is the example of benzaldehyde. It will take place in the presence of conc NaOH. Okay, heating will take place and what will happen? Benzyl alcohol, which is the reduced product, and then sodium benzoate, which is the oxidized product, it is formed. Very important Cannizzaro reaction also you need to learn. Now let us see the last reaction, which is electrophilic substitution reaction. See, it is for aromatic aldehydes and ketones undergo electrophilic substitution reaction at the ring in which the carbonyl group acts as a deactivating group and it is meta-directing. Now what is the reason for it? It is due to minus R effect. And if you draw all the resonating structure, then the electron density is decreased at ortho and para position in comparison to meta position. So you need to remember that these are what? Meta-directing. Aromatic aldehydes and ketones are meta-directing. Only one reaction is shown in your NCERT. Benzaldehyde will react. See, nitration is shown to form meta-nitrobenzaldehyde. Okay. So I hope, see, this reaction we have studied already also. You have to just remember that it is meta-directing. I hope all other reactions are clear. See, one more topic is there. Since you know from this chapter aldehydes, ketone and carboxylic acid, nothing has been deleted. So uses of aldehydes and ketone also you need to remember. See, one thing is formalin, that you need to remember, it is 40% solution and it is used to preserve biological specimens. And then rest you need to remember that acetaldehyde is used primarily as a starting material for manufacturing of acetic acid, ethyl acetate, vinyl acetate, polymers and drugs, and benzaldehyde is used in perfumery and dye industries. So these are some of the uses that you need to remember, and you can also remember about vanillin and other it is uses of aldehydes where they are used because of their odors and flavors. Okay children, so here we come to the end of the topic, which is chemical properties. Aldol condensation I have discussed with you. Okay, and in this I have told you very important trick how to write down the product for both aldol, self aldol products and cross aldol products. Cannizzaro I have discussed, and electrophilic substitution reaction also I have discussed, nitration. Thanks for watching the video.